Here we go with question number 6. The given information is we have a hot air balloon and it's filled with sulfur dioxide, which is foolish because sulfur dioxide is very dense, as you've seen. But let's do the problem. Suppose we want to make the density less than that of normal air. Here's normal air right here. It's an inequality, but I'll start with the equality. Could we make SO2, which is 64 grams per mole, equal to 1.25 grams per liter? And the answer would be yes, if the liters are, well, that's what we'll calculate. What do the liters have to be? 64 grams, that's 1 mole. How many liters would that be? So I'm hoping you can do the math. I got 51.2 liters. So if 1 mole SO2 occupies 51.2 liters, then density is equal to air. D equals air. All right. Let's figure out at what temperature this will be true, where 1 mole of SO2 is 51.2 liters. So this is best done with PV equals nRT, ideal gas law. We can say pressure will assume 1 atmosphere. It's not stated, but when it's not stated, that's our normal pressure. The volume we know is 51.2 liters. The number of moles is 1. R is what it always is, and T is the variable. At what temperature will this be true? I'm rearranging the equation a little bit. T equals PV over NR. So scientists often rearrange equations. This just comes from here. And now I can plug in the values I have. P is 1 atmosphere. V is 51.2 liters. I'm labeling these numbers here, but I won't use them in the actual calculation. I'm just identifying all the variables. 0.082 is R. Okay, so that's a calculator problem. Pretty easy calculator problem. 51.2 divided by 0.082. I have T equals 624 Kelvin. So if I want to turn that into Celsius, I can take away the 273, and that will get me some number that is easier for me to understand. 351 degrees C. That's really hot. So it is possible to make the SO2 expand enough that it would reach a volume of 51 liters, but it needs to be very hot. If we don't heat the SO2, you've already calculated that above, and it's very dense gas. So since we say reach a density less than that, you could make this an inequality now and say that the temperature must be greater than 351 degrees C in order to make the density less than that of normal air, which is what would be required to have the balloon float.